So welcome YouTube. This is Beautiful Mind Pfeiffer. What we're doing, we're going to continue. Oh, notifications are still coming through. Let me see. Yeah, whatever. I'm not going to worry about that. So we're going to. This is the first lecture of our Precalculus course. So we're going to start with Chapter 5. This is Section 5.1. Section 5.1, angles and their measures. Okay. So some of the objectives, we want to convert between decimal and degrees, minutes, and seconds, measures for angles. We want to find the length of the arc of a circle, convert from degrees to radians and from radians to degrees. We want to find the area of a sector of a circle, find the linear speed of an object traveling in circular motion. These are some of our objectives. Anybody want to just kind of share their experience with like either trig or trigonometry, or like if you hear the word trigonometry, what does that mean to you? If you dissect it or break it apart into smaller pieces. Tell me your last name again. Mr. Hightower. Just try to keep it as Mr. Shapes, right? Exactly. Exactly. Like that's exactly what we're going to be doing. When you see the prefix tri, what does that mean to you? 3, right? If you see trigonon, what does that mean? What shape is that? Triangle, right? So trigonon is triangle. Trigonometry. Where else have you seen ometry? The suffix geometry. What is geometry? What is geo? Shapes. What is geometry? What do you do in geometry? How shapes do what? Where else have you seen ometry? Have you seen ometry anywhere else? So ometry is, yeah, that's what we're. So ometry is like, it means measurement. Ometry, the suffix ometry means measurement, all right? So trigonometry means triangle measurements. So we're going to be using, stoichiometry. So I don't know Stokio. Is it like? We didn't do that in science. I've heard it. It sounds chemistry, right? So the how the subatomic particles, the charges on the subatomic particles. So the measurement of subatomic particles. Ometry is the measurement of. So trigonometry is triangle measurement, right? So go ahead. Right, we're going to be getting into all that. Sine, cosine, tangent, what do we mean by this? And so I felt like this is a little bit more appropriate. I'm getting comfortable now, taking my shoes off. Hopefully you don't start craving like Fritos or anything like that. She looked away. She was like, I cannot today. I told you I'm going to shift up the energy just to keep it as live as I can. But yeah, I'm totally getting comfortable up here. I got my shoes off. I'm just kind of chilling. But yeah, so these are some of the topics or ideas that we're going to kind of be exploring. I'm still getting my notifications, but that's okay. Okay, so let's kind of keep going with it. How many slides altogether today? Oh no, I didn't want that. 39. Okay, that's what I needed. Okay. So we're going to introduce with some terms. We're going to start out, typically these sections start light, and then as we progress through a section or a chapter, the ideas, start to compound, right? One of my mentors, or one philosophy is that there's no such thing as a complex. Complex is only a long string of simple ideas. So a lot of times people get intimidated because there are some simple ideas that are missing, right? So no such thing as complex, just complex is a long string of simple ideas. So we're going to open up with some terms. When two rays are drawn with a common vertex, they form an angle. We call one ray of the angle the initial side and the other the terminal side. All right. So if we're looking at this far left example, right, we have the initial side is where, so what is a ray? What is a ray? What does that mean? Ray. What is a ray? So a ray is this. Close. A line segment is if you have two endpoints, right? A line is a straight edge that goes in opposite directions forever, right? So a ray is like pretty much half of a line. It has one endpoint and goes one direction forever. So with the angle, we're going to introduce angles with this idea of a ray that has the initial side is going to be the starting one. So that's the part that you see at the bottom, and then that's going to be the starting ray, and then we're going to go through some kind of rotation. If I were to say clockwise versus counterclockwise, trying to hide the solution, which way did this angle that you see, which way did this rotate, clockwise or counterclockwise? Which?
I thought clockwise was going this way.
So if our hands are at noon, and then where's 1 o'clock, to the right or the left? To the right. Then 2 is, so that's clockwise. But if the initial side is at the bottom and the terminal side is at the top where we end it, so this one is counterclockwise, right? So we're going to say counterclockwise rotation is the positive rotation. We're going to say that's it's rotating in a positive direction. Counterclockwise is a positive rotation, right? So this one is rotating counterclockwise. We're going to consider this to be a positive angle. The angle here is, we're going to call it alpha. So it's just alpha, just like the Greek, alpha, beta, gamma, all that stuff. I need to learn that. I probably know it. I just hadn't thought about it. But yeah, we're going to call this one a positive rotation. So then with this one still has the same initial side and the same terminal side. But now, which way did this angle rotate? If we start at the initial, notice it's rotating clockwise because it's going the same direction as the hands on the clock, right? So we consider this clockwise. This is what we will call a negative angle, or it has negative rotation. This angle has negative rotation. Right, okay. So this one's rotating clockwise, and we'll call this a negative angle. Ooh, slow down. So then this last example, again, it has the same initial side, the same terminal side. So it started with the same ray, the ray in the same position, and it finished with the ray in the same position as the previous two. Is this rotation clockwise or counterclockwise? It's going the opposite direction of the hands on the clock, right? So is this angle, is this a positive angle or a negative angle? Positive. Counterclockwise is positive. Okay, this is a counterclockwise rotation. This is a positive angle. So we just saw examples on what we mean by a positive angle versus a negative angle. What do we mean by initial side versus terminal side? Yeah, and these are all called coterminal angles because they have the same initial side and the same terminal side. But all these angles are different angles. But these are called coterminal angles because they have the same initial side, the same terminal side. But these are actually 3 different angles. Yeah. And I think we have a slide that should say that. So an angle theta is said to be in standard position. This was that question that was in the homework that we never really answered. It says an angle theta is said to be in standard position if the vertex is at the origin of the rectangular coordinate system and its initial side coincides with the positive x-axis. So that drop-down menu that we had in Pearson, this is what it was talking about. All right. If we look at the angle in standard position on the left, this one here, what direction is the rotation? Counterclockwise. Is it a positive angle or negative angle? What quadrant is the terminal side in? Quadrant 2 is correct. So the upper right-hand corner, what quadrant is the upper right-hand corner? 1. So the upper right. So you see how this x and y axis breaks the flat surface into 4 sections? The upper right-hand corner is called quadrant 1. Then we go in the positive, the counterclockwise direction. Upper left is quadrant 2. Bottom left is quadrant 3. Bottom right is quadrant 4. Is this okay? Is this clear with everybody? Yeah. Okay. So this terminal side this terminal side is in quadrant 2. So we have a positive angle in standard position with the terminal side in quadrant 2. Go ahead. 1, 2, 3, 4. Upper right is 1. Upper left is 2. Bottom left is 3. Bottom right is 4. So it's like it goes 1, 2, 3, 4. Okay. All right. So this terminal side finished in quadrant 2. All right. What quadrant is this terminal side in? This terminal side is in quadrant 3. Okay, let me see if I think I can write on here. So let's go like this. I think it's already ready. So what I'm saying is that let's can we undo? How do I undo? Let's go like this. And then let's do not that one. What color are you feeling today? Red, orange, green, blue, black. Black. Okay, black is fine. Black is beautiful. So we're here. Upper right is quadrant 1. Upper left is quadrant 2. Bottom left is quadrant 3. Bottom right is quadrant 4. That's what we were referring to. Is that okay? I don't know why it's done that way, but that it just is. That's a good point. I don't really know why it's that way. You normally think Now, see, now America, we do our things from left to right, top to bottom. But like in Japan, they do things like top to bottom, right to left. So now, like everything is reversed. You see what I'm saying? Like we drive on the left, and like I think in Europe they drive on the left in a lot of places. Is that right? But a lot of places around the world, everybody's on the right. It's like America's just like doing this something different just for the sake of being different. It seems like most people use the metric system. We're the only one that uses, what is it? Standard, whatever it's called, the feet and inches and all that stuff. Everybody else is like meters and kilometers and things. But yeah. Okay. So that was what I wanted to say there. Okay, I'm gonna let that be. So these notes are actually already loaded in Moodle. It's a good idea for you to actually print these out ahead of the time, look at them before class, and then that way when we get in class, it should be a review. Idealistically, you want to be reviewing when your teacher is first presenting it in class. If you're reviewing, you're actually ahead of the game. That's a good position to be in. I guess it's a positive. I don't know. I'm just trying to make some bad joke. Okay. When the angle theta is in standard position, either the terminal side will lie in a quadrant, in which case we say that theta lies in that quadrant, or the terminal side will lie on the x-axis, in which case we say theta is a quadrantal angle. Okay. So we kind of did an exercise like this. But you see in part A, let's kind of just do it again really quickly. So I think we see it there, but what quadrant is the terminal side in here? Try again. Two, right? And part B, what quadrant? 4. And part C, what do we call this? So it's a term we literally just introduced. We call this a quadrantal. Because the terminal side ends on one of the axes, we call that a quadrantal angle. Go ahead. Yeah, the arrow shows you where you're starting from and where you finish. So the arrow shows you the angle and direction of rotation. Shows you the start and the finish. And then typically these angles are in standard form, where the vertex is at the origin and the initial side is the positive x-axis. Okay. All right, let's keep it moving. All right, so now let's look at degrees. A complete revolution is how many degrees? 360 degrees, all right? So if a complete revolution is 360, then let me see. So the angle formed by rotating the initial side exactly once in the counterclockwise direction until it coincides with itself is said to be a measure of 360. So again, a complete revolution, we call it 360 degrees. You see in the upper right, in the right-hand side, it says abbreviated 360. That little circle, raised circle, means degrees. So 1 degree is 1/360th of a revolution. So if we took that revolution, that complete loop, and we broke it up into 360 equal parts, 1 degree is going to be one of those parts. That's what we mean by 1 degree. All right. So a right angle is a angle that measures 90 degrees, which is 1/4 or a quarter of a revolution. Right. What are some examples of a 90-degree angle that you see? Edge of the table, right? The corner of what? Pretty much a lot of stuff, right? Right, we're surrounded by it. Now, apparently, this is not really math, this is something else, but apparently as humans, like our natural thing is like curves. Like nothing in nature like is really on a straight line. It goes on forever. Everything has curves and things like that. And so it's like, apparently like the straight edges and sharp corners and turns like that, that's supposed to be quote unquote a masculine energy. And then like curves and, abstract and things like that, it's supposed to be feminine energy. And so it's like, there's this play between the masculine and the feminine, between the straight, hard corner curves of that energy and then the curves of the other energy. And so there's something there. I don't know what it is, but there's something there with energy. But it's neither here nor there. It doesn't really mean anything. Go ahead. Yeah, so if you start here and do a complete revolution, when you get back to where you started, that's called 360 degrees. Yeah, you can go past it. It's just then you just kind of going in a circle. You just keep going past yourself over and over and over, right? So 360, if you go beyond like 370, now you just keep going. Like, yeah, you just keep going doing circles. So I don't mind if you take pictures. I don't do audio or video recordings other than what you see me doing. And keep in mind, again, this is already on Moodle, but I don't mind if you want to take a picture for your notes. I don't mind that kind of stuff. But yeah, a right angle is 90 degrees, which is 1/4 of a revolution around the circle. A straight angle is 180 degrees, which is half a revolution, and then things of that nature. Any questions so far before we keep going? Okay. Oh, and also, it's a good idea to go ahead and retrieve a copy of this stuff, because I don't really want you writing this stuff because you already have a copy. So I really wanted to be more conversational. Idealistically, what you all would do, you would load the notes before class, study it, do the best you can, probably work the examples as best you can, and then when we get in class, it should be a review. And then you pretty much just want to write anything that you see me writing. As we start working examples, that's the stuff you want to write, because that's what you're not going to have on your own. Okay, let's keep it going. So really quickly, we're asked to draw an angle. So it says to draw each angle in standard position. We got what? Ooh, I wish we had a board over there. Why is there not a board right there? Is this a smart board? This is not a smart board either. Are you serious? Is the board right there? I know. I wanted you all to come to the board. And so I was like, if we had something there, then it wouldn't be so awkward. And then usually the TVs are like smart TVs, but I don't see, this one's not. Somebody want to come? One person want to come and do this one? One person? It's Mr. Hightower, is that right? Yes. Okay. So I'm going to do the following. I'm going to do black. We got what? 1, 2, 3, 4. So we'll do A here. We'll kind of go like this. This is the positive X here. This is the positive Y. We'll do B here. Again, positive X, positive Y. We'll do C here. Positive X, positive Y. So give it a go. Here, you can come here. You can use the tablet, okay? You're just going to kind of stand at the podium. So keep in mind, again, this is an introduction. It's not going to stay at this intensity level. You can choose your color, one of the ones on the top. Okay. So just draw those for me. So the first one is 135 degrees. What quadrant should that be in?
That should be in obtuse, for sure, because it exceeds 90. And
so let's start off with our initial side. Where does the initial ray go?
Initial should go along the
So you can actually go ahead and draw the initial ray. You can actually just write on like paper. You can put your palm on it. You can rest on just write like paper.
Yeah.
Let me see. Can we make it? Can we make it thicker? Maybe not. No. Okay, that's okay. Yeah. So we have, and just try to make it prominent. Yeah, you can actually rest on the screen though. You don't have to hover. So that's the initial ray, and do an arrow so you know it's yeah, okay. So that's the initial ray. So now, what quadrant is that 135 going to be in? It doesn't have to be exact. It just needs to be in the right quadrant.
I'll say the second.
Okay, right. So he says the second quadrant. So just go ahead and draw the final.
I'm gonna go kind of like this.
That's fine. And then draw an arrow. And then you want to do a curved arrow to show your angle of rotation. So from your initial to your terminal, and then yeah, just like that, right? Yeah, probably like an alpha or something like that. That would be fine. Theta's fine, right? So quadrant 2. So if we're at the top, I know, right? If we're at the top, right, what angle measure is that? So let's start over. If we're at the positive X at the start, what angle measure is that?
1.
We start at angle, not 1, but 0, right? If we start at 0, once we go a quarter turn, when we're at the top, what angle measure? 90. We keep going. If we're a straight edge going this way, what is that? 180. And then at the bottom, we're at 270. And then 360 is back at the start, right? So with part B, if we're at negative 180, can you draw that one for me? Mm-hmm. So let's draw the initial side, right? So let's start with the initial side is, yep. And then your arrow so we can see it. Okay, there's our initial ray. And then if we're at negative 180, so we not only need to finish in the right spot, but we need the right angle of rotation. So if it's 180 degrees, where's it going?
Right now we're at 0. So that means we actually have to go on top.
And then
clockwise. That's a
negative. Yep. Mm-hmm.
So 90, 180. So actually be this.
Yep. And then,
But
yep.
to
And
do
then,
like that.
yep. And then, yep. That looks good. Any questions on what he's doing here? So if you can just kind of go ahead and do the.
That's out.
That's fine. That's fine. Yeah, that's okay.
So it just negative, it goes the opposite.
It goes clockwise. All right.
Oh yeah.
All right. Go ahead and do the other two.
See, that's easy. Just a normal right angle.
That's a regular right angle. Okay.
How does it look? And just like a B.
That's fine. You can do theta or whatever. And then the last one is 495.
Okay. Yeah, I got it.
Okay.
So it's gonna be a full, at least a full circle.
Okay.
So 360, 6 plus 9.
Let's do this. Let's do the following. Hey Siri, what's 495? Is it gonna work? Let's just try it again.
495
What?
minus 360.
Hey Siri, what's 495 minus 360?
495 minus 360 is 135.
Did you know that Siri could do mathematics?
Yes.
Oh.
0, 0, 0, 0.
She could do a lot of stuff. Yeah, she could do like some. So you saw the measure angle.
So
So.
135.
Mm-hmm.
Okay, so then all to do is
I'm telling you.
Is it not registering? Let's see. Let's go back. Like that. Just try it now. Is it still not working? The battery could have died. Okay. I don't want to disconnect it. Let's just use your finger. Yeah. Because I think the battery might have died.
it's nasty.
That's okay. And then it's gonna finish there.
Ew.
And
It's
then that's
nasty.
okay. And then now, if you did a positive 495 degrees, how do we account for that angle of rotation?
So you go like
You see what he did? So he went past, right? And then just some kind of theta or something.
let's do my own symbol.
Okay. Okay, that was awesome. Okay, any questions here? Anybody want to this question or
That's why I said that thing was nasty.
our pen like died. I think I need to charge it. Let me try to charge it right now. Yeah, the
So he had used his finger.
huh?
He had used his finger.
Yeah, he used his finger. Finger. Okay. Let's go here. We'll clean up this later. I'm watching the clock. Give me just a moment. So now, hopefully you took your own notes. You have a copy of this because I'm gonna have to clear the screen. Unless I could copy it. I don't know how. Yeah, if you want to take a picture, that's fine. I'll pause for a moment, but I have to clear it to go forward. Okay. Okay, so I'm gonna clear this. Let me see. Let me go. Oh no, I didn't mean to add that extra stroke. Let's see if I can erase that, what I just did. Okay, that's fine. And then actually what I'm gonna do, yeah, okay, so let's clear this out. Okay, so let's see, how do we do? So an angle's 135 degrees. He finished in quadrant 2, right? One and a half right angles, right? So I think we're okay there. We're just reviewing like his results. So he finished that one in quadrant 2, so that one was good. He did the 180. He had the right angle direction of rotation. Okay. Then his 90, I think that was fine. And then he did more than a complete revolution for the last one. The finish it was a coterminal angle as the other, but he did a full rotation. So the angle, that's the circle. Oh, this is what he just did.
So the reason why you curve around is because it's greater than 360.
No, I know that. I'm saying like, why would it not get it?
Oh, okay. So let's back up. So he had this, right? So what the PowerPoint is doing is just taking each of those and focusing on, like, part A was 135. So we looked at how to draw, right? 135. And then part B, how to draw it. So where he did it on one go, they took each one individually. Yeah. Okay. Oh, the cops. Yeah, it's kind of ridiculous. Like the cops and then the train. And I'm like, it's ridiculous. And then it's like, but I've been in other parts of other neighborhoods, and the trains are just as quiet as can be.
You don't even know they
And then it's like, so I was like, wait, why is this the way it is? And then we're like, oh, they made a petition that they had to come quietly through here. I was like, we need to get that in our neighborhoods, but we have to organize and we have to band together and like put our foot down. It's ridiculous.
And I live over here, and I get tired of the train.
It's ridiculous. It's really bad. It's not, and it's like, but it's like it's all based in our ability to organize and come together and be on one accord as a unit, as a collective. But a lot of times we have been pitted against each other, and we still kind of get suckered into arguing and fighting each other. So as long as we fight each other, they can do stuff like that. But if we're as a unit, you know, saying, hey, no, we don't want, y'all need to be quiet when y'all coming through here. We're trying to study and grow.
Right.
Then if we like, especially if we have money, they're gonna listen. That's usually what it boils down to, is whether it's backed by money or not. Let's. I'm trying to at least get through this section so that we don't have to, you know. So we got a good ways to go. But I don't really want to rush, but, you know, I'm watching the clock. We don't have much time left. So the next objective we want to take a look at is converting between decimal and degrees, minutes, and seconds measures for angles. So let's see how this evolves. I guess I can bring this back down here. Thank you, Mr. Hightower. That was awesome. Okay. So 1 minute is denoted, as you see, as that 1 apostrophe, is denoted as 1/60th of a degree. So if we took that 1 degree and broke that 1 degree up into 60 equal parts, that's what we mean by 1 minute. So 1 minute is 1/60th of a degree. 1 second is what 1/60th of a minute, just like with the time, right? So 60 seconds is a minute, 60 minutes, an hour is like 1 degree, right? That's kind of how that goes. All right. So then let me see. One counterclockwise revolution. I don't know why I'm doing that. I was like, I don't care. One counterclockwise revolution. I'm trying to force myself to slow down because I want to talk way faster. I was like, nope, just breathe and just pace yourself. Don't rush through it. So one counterclockwise revolution is going to be 360 degrees. Again, 1 degree is 60 minutes and 1 minute is 60 seconds. So these are the conversions that we're going to use to convert between these different ideas. Okay? Let's get through this section and we'll pause for the cause. So first we're asked to convert 65 degrees, 9 minutes and 17 seconds to a decimal degree, to a decimal in degrees, and then round the answer to 4 decimal places. And then part B is asking us to convert 32.479 degrees to degrees, minutes, and seconds notation. Okay. We probably will just stop halfway through this section and we might continue next time. So what I'm going to do, I'm going to take a screenshot of this and I'm going to open this up in my note-taking software. Yeah, I'll get you. This is just an iPad. It's just an iPad. Like, we're talking about rent. I don't like that. Where's Notability? Let's go like this. Come on, just open. Oh, God. I don't care about any of that. Just import. Done. Just open up. Oh, my goodness. All right. Well, I'm not going to worry too much about that. I'm going to let that be. And I really want this. Huh? But it's actually all in the cloud. Like, it'll come and go just like that. Okay, hopefully. Let's go. I don't know why that didn't open. Hear it. Not that one. I think yeah, it should be this one, right? Let's go ahead and put it where it belongs. Yeah. So when you all start asking questions, this is pretty much what I'm going to do. I'm going to load it. I'm going to load it onto my tablet like this and then make dedicated videos walking you through your questions. Okay. All right. I think we're good to go. Come on. I'm trying to also give my pen a little bit of time to charge because I do remember that probably the battery was low. Hopefully I don't have to reconnect it. Okay. So let's see. What's the time? We got like 20 minutes. Okay. I'll convert this to a decimal in degrees. Okay, so decimal degrees. So hopefully this is still connected. Let me see. Okay, cool. Can I see something? Yeah, that's not what I want. Let me not. All right, I'm gonna let it be. Okay. Okay. So convert the 65 degrees, 9 minutes and 17 seconds to decimal degrees. Okay, so let's take that number. So we're looking at part A. Can I see the...
So I'm guessing you're gonna turn the minutes and seconds into decimals.
Yeah, okay. So part A, right? We have this, and let's back up. So like this, make it a little thicker. Part A, we have 65 degrees, 9 minutes, and 17 seconds, right? We want to convert that to decimal degrees, right? A degree in, a decimal in degrees. So 65 degrees is already in degrees, right? So we're just converting these to decimals. So let's convert that 9 minutes, right? So let's focus on that 9 minutes. We're going to start by putting it over 1, right? And then we're going to say times. Now, we want to convert minutes to degrees. How many minutes in a degree? 60 minutes, right? What color? Orange? We're going to do orange. I heard orange. So 60 minutes, we said, is what? 1 degree. So when we do this, notice, since we had minutes on top, when we do the conversion, we intentionally put minutes on bottom. And so now the units of minutes are going to cancel. Does that make sense? This is how we do conversions. So that means now when we finish, we're going to finish in the units that we want. We're going to finish in degrees. So then we just crunch the number. So we're going to, that 9 minutes, we're going to say 9 divided by 60, and the answer is going to be in degrees, which is approximately. Let's see. Hey, Siri, what's 9 divided by 60?
9 divided by 60 is 0.15.
Degrees. Okay? All right. I think I heard yellow. I'm going to try it here. A lot of times I can't see yellow, but then I think you all can. Let me see. Yeah, I can't see that. So I'm going to do, I heard lime green. I'm going to do darker green so I can see it. Okay? So now we want to convert seconds to degrees. How are we going to convert these seconds to degrees? What's a route that we could take? Instead of doing that, I mean, that's fine. What you said is correct. But how can we, what's another way where we can go from seconds to degrees? How many seconds in a what? How many? 60 seconds, right? So go on in 60 seconds. 60 seconds is 1 minute, right? And then we go from where? From minutes to how many minutes in a degree again? 60 minutes. Does this make sense? Where you got your conversion from? Yes. Yes. So this is who was here today. You can actually take this. Okay. This is who was here. It's just one person that was missing today.
Okay.
Oh, sorry. Yeah. So it's just one that's missing, but that's who's here. Okay. So Mr. Hightower, you said that 3,600 seconds is to 1 degree. You see where the 3,600 comes from? Is that okay with everyone? Right. So, but what I use for these, the simplest thing for me is I just know that 1 degree is 60 minutes, 1 minute is 60 seconds, and then with that, I'm able to do everything I need to do. So then we just crunch the 60 times the 60 under the 17, right? So let's do this. Hey Siri, what's 17 divided by open parentheses 60 times 60 close parentheses?
17 divided by 60 times 60 is about 0.00472.
So now, what do we do with those 3 results to get the final thing in decimal degrees? Try again. We just add them up, right? So we're going to say the 65 plus the 0.15. I think it all lines up. The 65 degrees, 0.154722. And then I think the instructions said to round to 4 decimal places. So if we're rounding this to 4 decimal places, what number do we need to look at? Well, give me a color.
Red.
Okay, we can do red. Okay. Give me a random shape. Sorry. Something more interesting, a random object. Not a shape, an object. Like a bear or something. Trombone. Something like that. Or whatever. Okay. So that's going to be our cursor for right now. Oh, no. Okay, good. So I'm just going to use that to draw your attention. So, it looks like a knife. So bad. Yeah. So this thing, let me do like this really quickly, so I can kind of help myself.
Wow.
Boom.
It looks like a something.
It's a trombone though. It's a trombone. Okay. So if we want to round to 4 decimal places, right? I told you we're gonna have some fun. Just a little bit. We're still gonna do our job, but we're going to try to have fun while we do it. That's honestly what got me through a lot of schooling. I tried to have as much fun as I could doing my homework. I tried to make a game out of it. I'm a gamer. And so my parents were like, people would hound me, it's like all this kind of stuff. Cool, I'm not getting no notifications. Okay, I think I'm okay. But people would hound me, it's like, you play too much. I was like, no, you just not. I was like, I refuse to not be myself. I just refuse. I was like, no, I know I can be myself and get the job done. So like with the homework, I would make a game out of it. I was like, okay, wait a minute. I need to finish this by this time and still allow time for rest and play, and so I can go over it again and ask questions. So then I would just make a game and like hit my marks. I'm the ultimate gamer. And then what's happening though, and you kind of got to be a little bit careful. I got to be a little bit careful, but I'll take my intensity in the gaming and I'll apply it to life. Sometimes it gets me in trouble, but I know that there's nothing I can't do. Like I know it. Like you can't. When people tell me no, I'll be like when I'm doing certain things, they tell me no, I'll be like, okay. But there's always a way. There's always a way. So I'm saying that to say, I just want you to, one, try to have fun doing whatever it is you got to do. And so that way it's not such a drag for whatever. All right. So if we want to finish with 4 decimal places, what number do we need to look at in order to round properly? This 2 right here. All right. One past our desired position. So the 2, does it say to round up or stay the same? Stay the same. So if we round this to 4 decimal places, what's the final result?
5.5247.
Okay, degrees, approximately. So we rounded it. So that's the result that we got there. All right, you see how this worked? We have the original question. We have our supporting work. I use colors because it helps with everything. Go ahead to part B. Let's go on to do a part B. So part B, it asks us to convert. Actually, you know what? Oh no. What I want to show you something really quickly. So we got this result, right? Let's take a look at the following. If I can get it to work. Come on. Now, that's what I want. Thank you. Then we're going to go like this, like that. Now, it should be here. Yep, right there. Come on. Come on. You know you want to. Come on. Come on. Oh, you're going to make me do it? Okay. Yeah, there it is. Okay. Reload and refresh. Come on. Trying to wait. Let's do it one more time. So this is hang on. Come on. Okay, I think it's working. It looks good. So this is a TI-83 Plus. This is a virtual calculator. I'm on a website called chemtech.net. What it is that some students at this institution came together and like they made a program. They basically made a virtual calculator. It's ROM, it's free. And it took me some years to find it, but they created it. I haven't gotten to the creation phase yet of this kind of stuff. But when I came across it, I was like, finally, this is exactly what I need. So I use this to show students how to navigate a graphing calculator. I mean, what you see on the screen is what's being broadcast. So, well, it's not an app. It's a website. It's a website, and it does take a little bit of like you got to download a ROM and then make sure it works properly. It takes a little bit of like being able to follow instructions. For my class, your ability to follow instructions is key. Like when I say basically, long story short, just do my homework. That's all you got to do. Once you have first you got to finish the homework, then you got to go back and do it a few times. But the sooner you can kind of do that, by the time the exam comes, you won't have any questions, right? But your ability to follow instructions, that's pretty much how you get through my class. Pretty much anybody's class. If you can follow your professor's instructions to the T, that's usually enough to kind of prepare you for whatever's coming, right? And then once you learn the system, that's when you can start changing the system. But if you try to change the system off the rip and you haven't duplicated the results, that's not a good look. That's like you're trying to bake a cake and you be like, instead of flour, I'm going to use, I don't know, cement or whatever, or like something. So whatever, you're going to try to change the system without actually producing a cake first. So you want to follow the system first, follow the instructions as best you can, duplicate the cake. Once you get the results, then you can go back and start changing things. So it's like, well, I'm actually doing an art piece and I'm not really making a cake, but can I bake a cement cake because I'm going to make this cake to make some kind of, whatever, you augment it to fit whatever it is you're trying to do in life. But the first thing is, upon introduction, just follow instructions. That's a simple thing, but a lot of people have a hard time doing it. And it's a difference between night and day. So I say that to say, you can actually use this. You can't use this on an exam. On an exam, you just got to bring in your own calculator. Just a regular, whatever kind of calculator you want to use is fine. But no cell phone calculators, no tablet calculators, nothing like that. But you can use a graphic calculator, right? You can use a graphic calculator. You can use a basic calculator, but nothing internet enabled. This is what I recommend.
I got a TI 84.
That's fine. Yeah, that's fine. That's okay. So now let's see how can we do this one. Let's see how we can put this example in the calculator and confirm our work, right? So one of the techniques in mathematics that made me fall in love with math is the ability to check the work. When there's more to that, but I'm kind of rambling, so I'm going to try to focus back. So let's put this original in. So we have 65. Now if I go to, okay, you see that blue apps kind of in the center of the calculator. It's a little button that says apps, APPS. I'm going to hit second apps to activate the angle, and I'm going to hit number 1. So it has 65 degrees. We have 9 minutes is, I see the seconds. I think if I go back to apps again, or the angle, number 2 are my minutes. And then we have 17 seconds. I think seconds is in right above the plus symbol. So if I hit alpha, wait a minute, I need my 11, right? 17, I mean. I hit alpha plus, and I should get my seconds. So then if I hit enter, we should get 65.154722. We should get that. If we want to take it a step further and have the proper rounding, I'm going to hit mode. You see the yellow second button in the upper left-hand corner? To the right of that, it says mode. I'm going to hit mode, and I'm going to float it to 4 decimal places. I think that does the rounding properly.
Oh my God, where was this when I did?
Look, I was here, but it's like we had to go through stuff to connect, right? Nothing happened. I don't really believe in chance. Hang on. Let me make sure it works. I think it works properly. I'm going to hit enter for the proper float. It's moving a little slow, which is making me a little nervous. And I'm going to hit enter again. And this is exactly what we got. All right? So the float does the rounding, but you have to be cognizant of it. This is all about awareness. We're just trying to expand our awareness. You can't really unsee this stuff, right? Once you see it, once it registers in your mind, that's all I'm really doing. And for my students, not that it's people here, but even when I have students in my presence that aren't conscious, then I'm talking directly to their subconscious. Because I know the subconscious picks up on everything. But I'm really trying to get you to the conscious level of a lot of this stuff. But I know on some level, yeah, I'm essentially brainwashing you. But I know that this stuff is going to come out when it needs to. But it's like if you want to have command over it, you got to get the repetition. So the more conscious we are, that's the more command. But I know it's going directly into your subconscious. So on some level, I know it's in you because you're in my presence. Anyway, so that's one angle. So we did that. I'm going to just kind of reload and refresh to kind of clear it out. I'm going to let that do. So we confirmed that one. If we get out in 10 minutes, I think we got time. Let's go ahead and do this next one. Any questions about anything before we go forward? Okay? Yeah, so you have to... Now, any other day, I can kind of walk you through and help you figure out your calculator. The day of the exam, I'm not going to know how to work any calculator. So you want to try to figure out your calculator before the day of the exam. I was using an 83 plus. 84 or 84 plus is essentially the same. 89s are a lot different. Then there's some others that are different. Yeah. Okay, let's go ahead and do this other one. So 32.479, 32.479, 32.479. We want to convert this. So this is in decimal degrees. We want to convert this to degrees, minutes, and seconds. All right? Let me think about how I used to do it. So I'm watching the clock. We'll probably make this the last example. I'll kind of glance at the next one. So now we want to convert this to degrees, minutes, and seconds, right? Let me think about how I used to do it. Okay, so the 32, we can just let that be, right? That's 32 degrees. That's a whole number, so we let that be, right? So first we're going to focus on this 0.479 degrees. Let's convert that to minutes. Is that fair? Somebody give me a color. What color are you feeling? Get something else that we haven't done. Pink is okay. All right, so let's convert this to minutes. So now we're going to put this over 1. We're going to say times. How many minutes in a degree? 60 minutes is to 1 degree, right? So if degrees are on top, what symbol needs to go on the bottom when we do our conversion?
Is it the little line?
Degrees, right? They got to be opposite so they cancel. The units cancel, right? So if we have degrees on top, when we go to do our conversions, that means we need to put degrees on bottom. We said 60 minutes is to 1 degree. That's the conversion. Okay, is this okay? All right, so let's do something similar. So we cancel the units of degrees. So this result will give it to us in minutes. So this is going to be, let's see. Hey Siri, what's 0.479 times 60?
0.479 times 60 is 28.74.
So that's minutes. So those units are now minutes, right?
Right.
So we don't usually write it like that. So now we can essentially say that this is 28 minutes plus 0.74 minutes. Is that okay? So let's focus on that. And that's not a 4. I don't know what I'm writing. I'm just super geeked that you guys are excited. There's more. This is a story for everything, but I'm going to let it be. Anybody watch this show called The Office? Have you seen that show, The Office?
Office.
Yeah.
The office.
The Office. So over the summer, I binged watched The Office. It's like now one of my favorite shows. I identify with so many of the characters, and it's a little embarrassing, but I feel like, so you've seen The Office? Have you seen it? Somebody seen it? Okay. I'll let it be then. But I identify with a lot of the characters on there. It's just funny. It's just, yeah, it's really silly. Yeah. So we've done the minutes. Let's go ahead now. Let's focus on that 0.74 minutes and convert that to seconds. So we have 0.74 minutes. Same kind of deal. Give me another color.
Purple.
Purple. So now we want to convert minutes to what? Seconds, right? So what's the conversion between minutes and seconds? 60 what? 60 seconds is
1 minute.
1 minute, right? So if we have minutes on top, what units need to go on bottom? Minutes. The same, because they get. It's okay. Repetition. The proof is in the pudding. Repetition is the key. What we do the longest, we do the strongest. It's okay. It's okay. I don't know if you caught all that, but the proof is in the pudding. Repetition is the key. What we do the longest, we do the strongest. I was born at night, but I wasn't born last night. Anyway, that one didn't fit. But anyway, so we said 60 seconds is to 1 minute. So now we set it up properly. The units of minutes cancel. We're going to finish in seconds. And let's look at our answer. Hey Siri, what's 0.74 times 60?
0.74 times 60 is 44.4.
So this is 44.4 seconds. Do we have any leftover? We got a little bit. We have a fraction of a second, but we're okay. So now if we want that original thing, let's put our final answer in another color. Give me another color.
Purple. No. Blue.
Tangerine.
Blue.
Have we done orange? Purple.
Gray.
Orange is right.
Brown, we haven't done brown. So the final result we got, so we're saying that this decimal degrees, in degrees, minutes, and seconds is going to be, we have, let's see, it should be 32 degrees. I think I did it proper. We're going to find out if I did this right or not. 28 minutes, and let's see if it says, there it is, to the nearest second. Okay, so if our seconds are 44.4 seconds, what's the nearest second?
44.4 seconds.
So does it round up or does it stay the same?
It stays the same.
It stays the same, right? So it should be 44 seconds. So let's see how do we do. First, before we look at the answers, let's go back to our trusty dusty Rusty. Yeah, that's what happens when you're having fun. It's like time flies when you're having fun, and then it's like you get the information and you do the things that you need to do, and it was no effort. It was not a challenge at all. There was no effort in what we did. Let's go ahead and close this out. Hang tight, hang tight, hang tight, hang tight. Ladies and gentlemen, hang tight, hang tight. Okay, let's confirm. So we checked the first one already. Let's check the second one to see how do we do. So the second one, we have this 32.479. Let's go to second to activate angle. We're going to hit 1 to, come on, why is it moving so slow? So we got that. I think if I just hit enter, no, I'm going to hit, go back to angle, and number 4, degrees, minutes, and seconds. So it wants us to put the answer in degrees, minutes, and seconds. If we hit enter, we should get, let's cross our fingers. Drum roll, please. Oh,
We got that.
34.
Wait, did we get 14?
Oh, wait a minute.
Wait.
Wait a minute. Something's not right. Let's think about, okay, I got it. Let's pull it back up. I'm going to go to mode. I'm going to put this in degrees and see if that makes a difference. So when we're doing trig, we have to be clear about, I think this is what we need. Let me just try this and see if it works.
The type, the mode type, and
Yeah, since we're doing degrees, and if this doesn't work, I got one other thing to make sure that it works. Yeah, so we're good to go. So we had to change the mode from radians to degrees. So we'll talk about radians and degrees and what we mean between those two and how to convert. But long story short, we got it right. Let's pause for the cause. Are there any questions, comments, or concerns about anything? So hopefully you were taking notes of the stuff that you saw on board. Let me go ahead and do this. So now when I'm using Notability, this stuff here, let me show you the following. If I did all the notes in here, I would hit share.
Can you scroll down for me so I can get all this?
So just hang tight. So I'm gonna hit share. I'm gonna hit box, and I'm gonna actually put this somewhere where you can access it. So right here, this is this one, fall of 2019. This is Precalculus, right? Precal, right? Right? Entire class, and I want to put this into the notes for today. Let me actually, before I do that, let me label this. What is this? Just say day 1 notes. We'll say day 1. So give me just a moment. Day 01. What do we do? 5.1. 5.1. Angles and their measure. Just hang tight. Partial notes. I'll say partial notes. Partial, nope, yeah, partial notes. Using the swipe key feature. I was waiting for that one. Okay, I'm gonna let that be done. Okay, hit done. I'm gonna hit share. Hang tight, we still got a full minute. I'm gonna go to box here. This is 2019 Precalculus course files into the notes section. I labeled it as day 1. I want to export it there. I want all the pages in the box. Now, so whenever I use Notability, I can pretty much load a copy of what I'm doing into that link, that box link. So as soon as that bar loads, you'll have a copy. Hopefully it'll go through. I'm gonna just try to let it sit for a minute. Just hang tight. While that's working, so yeah, we've had the 3 extra credit opportunities. I'll get a copy of this. Are there any questions about anything before we part ways? Go ahead. Oh, you know what? Say it again. Can it be used in? Well, the stuff that we're talking about? It can be. I don't know the practicality. It depends on your lifestyle and like what you're doing. But it definitely has, honestly, everything that we use have these applications underlined. This is like the underlying structure of all the stuff that's going on, like with the communication with the cell phone towers and the patterns and traffic signals and like when we go to stores, the queues, this is all over the place. This stuff is in almost every aspect of our life, but we're just not aware of it. So a lot of times with the mathematics, I inform my students like, hey, you actually already know this stuff. You just don't know that you know it. So we're going to actually take a look at things that we already know, and I'm just bringing it to your awareness or attention. So since that bar loaded, I'm going to show you how to access it. So if we go back to Moodle really quickly. Come on. My computer's trying to slow down. Okay, well, but if you go to Moodle and you go to that box link, that's how you can access it. It's in there. That's fine. I'm going to let that be. So we're going to end right there. I can't get it to act properly anymore. So I'm going to let that be. It's done. Okay, any questions? Okay, lovely people. It was great. So I will see you to this, what, Tuesday? I'll see you. Oh, today is Thursday, right? No, today is Tuesday, right? I'll see you Thursday, right? Have a good afternoon. Yeah, I'll see you Thursday.